Alright guys, so I had a couple of questions over how to label E and Z, so I'm going to go ahead and go through some example problems. I feel like just going through some example problems would be the best way to do this. So this is 7-33 from your book, and I'm using the 6th edition, so it may or may not match up with what you had if you're using the 7th or the 8th or the 9th or what have you. So let's go ahead and start this. So the first thing you want to do when you get some sort of alkene where you want to label E and Z is draw a straight line down your double bond. Right? Okay. So at that point, you want to compare the two. Let's not draw. The first thing you want to do is you're going to compare these two groups and these two groups together, right? And you're going to compare them by means of atomic weight and priority and whatnot, right? The one of them is going to have a high priority, the other one's going to have a low priority, and that's going to be determined by atomic weight, or weight, and by the first point of difference. So if we go off this carbon, let's erase that. There we go. Off this carbon, we hit a carbon on the top, and we had a hydrogen on the bottom. Hydrogen, and then we hit a carbon. So obviously carbon is heavier than hydrogen, so this has a high priority and this has a low priority. Next, let's go to the right side and compare. So we have a carbon and we have a chlorine. This time the bottom one is heavier, right? Chlorine. So this gets a high and the top one gets a low. Right? So again, you're comparing the two groups on the left together and then separately comparing the two groups on the right. Next, you're going to want to draw a big line through your carbon-carbon double bond. And you're going to want to look at your two high priority groups and see if they're on the same side of that line or if they're on the opposite side of that line. Right? In this case, they are on the opposite side. You can see we have one of them here and the other one there. So this would be E. Let's look at the next one. Right, so for this one on the left side, we're comparing a hydrogen with a chlorine. Obviously, chlorine gets the high priority. Hydrogen gets the low priority. On the right hand side, we're comparing a methyl group with a methyl group. These are two of the exactly same things. So remember back when we did RNS and we did that cube thing on one of the worksheets, and we went through and we determined that, well, these two chains are exactly the same. Then actually at that point we determined that two groups on our chiral center were the same, and therefore we couldn't even label it RNS. It's the same exact thing here. So we get to a point where we can't determine which one is a higher priority than the other because they're exactly the same. So that's just it. So this is neither RS, neither E or Z. In fact, you wouldn't even have to specify stereochemistry here. Right, so neither. And that's because the two groups on the right hand side were the same. Now let's look at the bottom one, and I'm going to change colors so that we don't get confused with the work from the top. On the left hand side for C, we have a phenyl group, and for those who aren't too familiar, a phenyl group is a benzene ring, right? So these are all double bonded carbons, and then the rest of the thing that it's connected to is there, right, on one of the ones. Right, so it's basically a carbon that's connected to other carbons like that. And this is just a methyl group. So again, we're going by the first point of difference. So carbon is the first thing we're going to get here, and carbon. In fact, let me go ahead and erase that and draw in what it really is. I feel like that would be a lot better. So that was a phenyl group, so I'm going to go ahead and draw it. There we go. And it wouldn't matter if you put your double bonds here like that, or if you put them the other way, if you just shifted them by one bond. Draw that really quick. So if you do them right here, and right here, that's exactly the same thing, so don't worry about that. Okay, so if we go one bond off that way, we hit a carbon, and then we hit a carbon going down as well, so those are the same thing. Let's move to the next one. On this carbon, we have bonded to it C, and then double bonded to another carbon, so that would be 2 C's. And on the bottom carbon, we have, well, 3 H's, right? Clearly, the top one is higher priority, so I'm going to go ahead and label that high, and this one is low. On the right-hand side, we go through exactly the same thing, right? We have a carbon here, a carbon here. Those are the same, move to what's connected to them. The top carbon is connected to a carbon, a hydrogen, and a hydrogen. The bottom carbon is connected to 3 hydrogens. So top one wins, right? This gets high priority, this gets low priority. Once we do that, let's go ahead and draw our big line down the double bond. And we can see that our high priority groups are on the top, both on the top of that line, right? So this would be Z, right? Because Z for zusammen, which means together in German, right? That's cool. And then finally, let's do the last one, right? Let's do this one in red. I like red. Okay, so left-hand side, carbon, hydrogen. Clearly carbon wins out. This gets high priority. This gets the low priority. Cool. On the right hand side, carbon, carbon. No help. Connected to this bottom carbon, we have an oxygen and 2 hydrogens. Connected to the top carbon, well, it's not really connected to 3 things, is it? We only have an oxygen and a hydrogen there. Remember, this can be expanded as C double bonded OH, right? This means aldehyde. And you can do that by doing the Lewis dot structure or going through it, or just like COOH is carboxylic acid, and we know what that looks like. COH is aldehyde, double bonded oxygen, right? So I'm going to go ahead and replace that with what it is, and then erase my little work here. And then we can tell what the 3 little triplet is, right? So this is doubly bonded to oxygen, so O, and then single bonded to hydrogen, right? And again, we go by first point of difference. First element here is an oxygen. First element here is an oxygen. Those are the same. Move to the next. Oxygen on the top one, hydrogen on the bottom one, right? So the top one has a higher priority. High, low. Notice it has a higher priority even though the bottom group has a higher weight in total, right? Again, you go by the first point of difference. And because double bonds are double counted, a lot of the times they get higher priority regardless, right? So we have our priorities labeled. Let's go ahead and draw our big line. It's purple. I like purple. And we can see, so back to green, that our high priority groups are on the same side of that line again. And therefore, we're going to have Z. Right? Okay, I hope that helped out. Email me if you have any questions, or post it in the comments. I'll get back to them. Y'all, good luck on your test.